here in Blackboard, there's kind of two topics mashed into topic 2 because they're kind of adjacent, but I wanted to show them separately. So I'm just doing topic 2A, and then I'll do topic 2B here in a little bit. Topic 2A is tuples. So tuples are like lists. That's where I was telling you at the beginning. I'm kind of comparing everything to lists. Tuples allow mixed groups of integers, floats, strings, objects of mixed type in general. The difference is that a list is what is called a mutable object, and a tuple is an immutable object. And that essentially means that a list can be changed at any time in the program in any way that you please, whereas a tuple is kind of either created prior to runtime, or if it's created during runtime, it is then kind of stopped that way. It is kept that way. You can't manipulate it in the same ways you can a list. So I just said that. So here I'm creating a tuple. Now, one of the weird things with tuples is that if you just, here you can see I'm creating tuples. So my tuple is the variable, and I'm assigning it this group of numbers in parentheses. So when you put a group of numbers together in parentheses, that is considered a tuple by Python. The weird thing is that I don't actually need the parentheses on the beginning and end, as long as I have at least 2 numbers or 2 items in my tuple. It will just assume if I just said, for instance, my tuple equals 4, 5, it's just going to make it a tuple. It just knows that's what you want. But if you have a tuple of length 1, you have to put the parentheses around it. Otherwise, it doesn't know how to handle that. So I would say best practice, just always put the parentheses around it, because it just, makes it obvious. But you don't have to. You can get away with it. In most cases, when somebody does this without the parentheses, they're actually doing it by accident. But I just wanted you to be aware that that's what's going on. So I'm creating a tuple, and then I'm printing my tuple. So I can just hit here. You see now I've got my tuple, 4, 5, 1, 8, 16.9. I guess I could have done print type my underscore tuple. And you can, oops, I forgot that parenthesis. And you can see that it's class tuple. Now I have this comment down here, commented out code down here, and that's because I wanted to show it to you working. And now I want to say, hey, I want to make my tuple position 3, which would be the 4th item. I want to change 8 to 345. I want to manipulate or edit my tuple during runtime. And you're going to see I can't, because you're not allowed to edit that tuple in place once it's created. So it's immutable. Continuing on, you can do a lot of things with tuples anyway. They can be created, obviously, accessed, copied, etc. So here is, I've got my tuple extension, which just has 2 items in it, 7.9 and 18. And I want to create a new tuple that is the concatenation of my 2 existing tuples. So I can do my new tuple equals my tuple plus my tuple extension. And Python knows if I'm combining 2 tuples that I am trying to create another tuple. So you can see I'm going to print my new tuple, and then I'm going to print the type of my new tuple. And here it is. It's the original one, plus I've added 7, 9, and 18. And now you can see it's still class tuple. And now I have created another new immutable object in my program. I can recreate them during runtime. Sometimes this is a little bit kind of being sneaky. You're kind of misusing tuples a little bit, but you can do it. And there are times where it's valid to do it. So here's my original tuple. I'm going to just comment this out so you can see it. You can see I've got my original tuple, 4, 5, 1, 8. And 16.9. And now I want to take the first 2 items of my tuple, because I'm taking index 0 and 1. I want to put a 7 and a 2 next. And then I want to grab items, index position 4 through the end of my tuple. So what I'm essentially doing here is I'm inserting 2 more numbers into the middle of my tuple. And then I am reassigning it to my tuple. So it seems like I'm manipulating the tuple, but what I'm really doing is I'm recreating it. I'm creating a new immutable object in place of the old immutable object, kind of like I'm editing it, but I'm doing it in a way that allows me to do it with tuples. What happened here? So, oh yeah, see, it replaced items index position 2 and 3 with 7 and 2 instead of 1 and 8. So I was able to sort of edit my existing tuple by just overwriting it in place. So before I move on to the next thing, because I didn't realize that was the next slide. So a tuple is something that if you were to put one in your program, you're kind of signaling that this is a thing that I am storing, maybe a list of information that I don't really expect to be changing in the program. It's just something I'm creating to have available there. Or if you're looking at somebody else's program and they're using a tuple, that's a signal to you to say, hey, this is something that's being created, but it's not really supposed to be edited. But again, as I showed you, you can get around that if you need to make adjustments to those tuples. You could also just convert a tuple into a list if you wanted to make it more editable, or make a copy of it as a list if you wanted to manipulate that data without attempting to edit that immutable object. So continuing on to topic 2b, so this is in that same folder in Blackboard, but it's kind of a different topic, arbitrary function parameters. So last week we looked at function parameters where we had default values, which allowed you to have some of the variables have preset values that you would use most of the time, but you could override them. What arbitrary function parameters do is that they allow you to send n number of variables to the function, and the function is able to handle that. So you could create a function that takes 1, 2, 3, 4, 100 variables, and that same function could handle it without you having to preset the number of ones that could be input. So here is an example. I have got to define my function, and then you see this star here, and this star indicates that it is going to take any number of inputs. So it could be 1, 2, or 1,000. So it's going to take that input, it's going to say total equals 0, and then it's going to say for number and inputs. I'm doing a for loop that I'm saying for every one of the inputs that's sent to me in this function, I'm just going to add them up. I'm going to make total, add that number, and then keep for looping around until I've gone through all of the inputs that are sent to me. This is one way to use variable inputs. And then it's going to return the total. So I could send it 10 numbers, it would total them up and give me a return. I think you can kind of see the power of that to make a function much more generic, much more widely usable, because you don't have to concern yourself with, I'm going to send 3 or 4 or 5, or I'm going to tell it how many I'm sending ahead of time. It's just going to be able to handle any number of inputs. So I'm going to run this, and then I'm going to utilize it. So you can see the first time around, I'm just going to send it the number 7, and it's going to return 7, right? But the second time around, I'm going to send it 7, 9, 12, 30, and it's going to add those up for me and return that number. And the third time, I'm just going to send it nothing, and it can handle that fine as well. So you can see 7, 58, and 0. So that same function can take a varied number of inputs. You also have an item called keyword parameters. And while I'm going to introduce this, I think I introduce it next, it is much more useful when we utilize dictionaries. So a keyword parameter is a parameter that you send, like you can say, I don't know, age equals 7, gender equals female. You're defining each one of those parameters as you send it. Dictionaries use that really well because a dictionary is a key value pair, a series of key value pairs. But again, we'll see that next week. But here's one where I'm taking keyword inputs. So you can see, define my function with keywords. When you have 2 stars, that means you are taking any number of keyword parameters. Now, a lot of times you're going to see, like if you go out to Stack Overflow or whatever, you'll see a function. I'm going to edit it, but I'm going to undo it afterwards. It'll say something like star arg, comma, star keyword args. And this just means this function can take any number of parameters, and then it can also take any number of keyword parameters. That's all that means. It doesn't have to be this. It's just a lot of times you see that people use this. You can use anything you want. The thing that defines it is the star for parameters and the 2 stars for keyword parameters. That's all that means. So I'm going to put it back to the way I had it. And I am going to get, each one of these is going to be a key and a value. So I'm going to do a for loop that says for, this will be the key, this will be the value. Again, we'll see some more of this next week. In the items that are coming in, print the label and the data. I know this is a little weird because we haven't really seen it. But I'm going to utilize that. I'm going to call my function. I'm going to send it a name and a language. and it's a keyword pair. See, its name is the key, and then the value is Matt. Language is the key. Python is the value. And then I'm going to print nothing because I want to put blank line there. But you can see when I run it, it prints those items out for me. And then I do it again with shape rectangle color blue. So shape rectangle color blue. So it's allowing me to send a variable number of inputs. I guess I do 2 in both cases here, which isn't a great example. I could do any number of them. I could do 50 if I wanted, and it handles those appropriately, no matter how few or many you send.